Hey guys, hope you're well. So in this lesson we have a grade 11 mathematical literacy paper 2. It's 100 marks and 2 hours. If you want to download the paper, just check the description below. The table below shows the relationship between hours and the rate of charged per hour or part thereof. Okay, wait, what? It's a parking. Okay, so we're parking, and if you park for 0 to 2 hours, then you will pay 5 Rand per hour. Okay, so 5 Rand per hour. If you park for between 5 and 6 hours, you will pay 15 Rand per hour. So that's a per hour, okay? That's not the total price, that's the per hour. If you lose your ticket, you will pay 50 Rand plus additional charges. Okay, plus additional charges. Okay, I guess the additional charges is you're still going to have to pay for how much you parked for. Okay, but we'll see as we go along. Right, so let's see here. What is the rate charged if Mr. Sokotu parked his car for 8 hours and 15 minutes? Okay, so if you are 8 hours and 15 minutes, you are going to be over here, and you are going to pay 40. You're not going to pay 40 Rand in total, but you're going to pay 40 Rand per hour. So let's say here 40 Rand per hour. Now they want you to write 8 hours and 15 minutes in hours. Now a lot of learners get this wrong because they do this 8.15. Not correct at all. You got to be careful. The 8 is correct. You can say 8 point. Now 15 minutes. You got to try think about what fraction is that of an hour. So we know that 1 hour is 60 minutes. Okay, so to change this 15 minutes into hours, you can just say 15 divided by 60, and that'll give you 0.25. So you must say 8.25 over here. That confuses a lot of learners. Just remember that when you convert minutes to hours, you're dividing by 60. If you said 0.15, then you are dividing by 100. Okay, so the answer will be 8.25. Mr. TT lost his ticket. When looking at the security cameras, they could see that he arrived at the mall at 11:30 and it was now 14:20. How much time has lapsed? So how much time has gone by? Okay, so to go from 11:30 to 12:30, that would be 1 hour. And then to go from 12:30 to 13:30, that would be another 1 hour. So now we've gone 2 hours. And then to go from 13:30 to 14:20, well, you got to make sure you understand that that is going to be 50 minutes. 50 minutes. So the total will be 2 hours and 50 minutes. So you could say here 2 hours, 50 minutes. Calculate how much Mr. TT was charged. Now remember, Mr. TT is a naughty man. He lost his ticket. So when you lose your ticket, you pay 50 Rand. So he's going to pay 50 Rand. Plus, he also parked his car. How long did he park his car for? Well, 2 hours and 50 minutes. So where does that put him? That puts him somewhere inside here. So now we've got to think about this carefully. It says here, this is the rate charged per hour. So, if you park your car for 2 hours and 50 minutes, you're definitely going to pay for the 2 hours. So let's say 2 hours multiplied. Now, every hour is 7 Rand, so we're going to say 2 multiplied by 7 Rand. But guess what, guys? This 50 minutes, they're not going to say, oh, how much is it going to be if it's 50 minutes? No, what they're actually going to do is that they're just going to take all of this and they're just going to count it as 3 hours. Because that's what it says here. Or part thereof. So if you park for 2 hours and 1 minute, they're actually just going to take that as 3 hours. If you park for 4 hours and, let's say, if you park for 4 hours and 6 minutes, they're just going to say that that's 5 hours. They're always going to just round it up. That's what this part means. So if this guy's parking for 2 hours and 50 minutes, they're just going to charge it for 3 hours. So I'm actually just going to put a 3 over here. And so that's going to end up giving us 71 Rand. So that is how much this dude was charged. 71 Rand, 50 Rand because of the penalty, naughty man, and this is 21 Rand. And the total will give you 71 Rand. Refer to the rectangular diagram below and answer the questions that follow. Define the term perimeter. Well, let me quickly talk to you guys about perimeter. Let's say you have a shape like this. Okay, and inside here you've got a few, I don't know, maybe there's a room there. So let's say we're looking at this, it's the top view of a house. Now, the perimeter is the distance on the outside. It does not care about these parts over here. Nope, we don't look at that for perimeter. Perimeter is everything on the outside. So we can say here that it is the total distance around the outside of a shape. This question says, determine the perimeter of the rectangular diagram in centimeters. Okay, so everything is measured in centimeters already. So you're just going to, this is also going to be 210 centimeters, and this is going to be 100 centimeters. So you're just going to add those four numbers together. So you're going to say 210 plus 100 plus 210 plus 100. If we do this correctly, we should get 620 centimeters. 620 centimeters. Give the name of the scale found on the diagram. Okay, so we pretty much, in maths literacy, we look at two different scales. We've got ones that look like this, and then we've got these other weird ones which have these bars. And for example, this will be like a black bar, for example. And then this will be colored in over here. And then it'll say something normally like 1 and 2 and 3, and then this is like kilometers. You've seen those. Well, this one's called a ratio scale, because it uses a ratio. And then these ones here are called a bar scale, because there is little bars over there. Okay, so this one is going to be a ratio scale. This question says, explain what 1 to 100 means. Okay, so we've done scales before, and what we know is that this here is the distance. This would be the distance on the map or on the drawing, for example. Okay, the map or the drawing. And then this would be the distance in real life. Okay, so for one part on the map, it is actually going to be 100 times bigger in real life. So we can say that, well, let's say 1 unit on the diagram represents 100 units in reality or in real life. Identify from the list below a provincial road in South Africa. Okay, now we've got these letters N, R, and M. Let me quickly give you a summary. N stands for national. Okay, those are like the biggest kind of roads, like the N1, the N2, and you can use those roads to go pretty much all over South Africa. Then you get a little bit smaller, we get R, which stands for provincial. Provincial, so these are roads typically within the province, so within the Western Cape. You can get around the Western Cape on that road. And then M is a lot smaller. It's usually you can get around a certain area, but that's called a metropolitan road. How do you spell metropolitan? Oh my goodness. Politan. Okay, so those are what those stand for. So they said, identify a provincial road. Well, provincial has an R, and so that's the R44. R44. Define the term provincial road. Okay, well, the way it works is that these provincial roads that we get in different areas, they eventually, if you follow them, they eventually feed to the national roads. Okay, so for example, here's a national road. Let's call this the N2. Okay, and then we've seen in real life on the N2 or on the highway, you've got off ramps. Okay, off ramps, for example. So these cars are going this way, these cars are going this way. Now they go on the off ramp, and then they get to, for example, there's a bridge. So this might be a bridge. And this road here going this way and this way, could be a provincial road, like an R44. So what I'm trying to say is that if you keep driving along a provincial road, you can eventually take an off-ramp and you can feed onto a national road. Okay? So on the memo, they say that provincial roads act as feeders to national roads. The Tylosaurus was an ancient sea animal that is thought to have lived 85 million years ago. The top speed. Okay, none of this actually makes any sense. Not sense, but we don't need to know any of this nonsense. I mean, if you're interested, go ahead. But yeah, you'll see it's not going to really affect the questions. Okay, so refer to the diagram below and use the diagram. Use the scale. Okay, so this is the scale over here. It's a weird scale. Okay, so it says write down the name. The first question, write down the name of the scale used above. So that's a bar scale. Remember, we've looked at different types of scales. You get ones that have like a ratio like this. That's called a ratio scale. And then you get ones that have, sometimes they do it a little bit differently. It looks something like this, where this one would be like a black bar, and then it'll have a gap. But as soon as you see bars like that or like that, then it's a bar scale. So here we can think of it as a bar. So what they're telling us is that this length over here is 1.9 meters. Now, if you try to do this question at home by yourself, you might not get the correct answer. The reason is I've obviously zoomed in or I've zoomed out. If you on a cell phone screen, it'll be different. So just watch how I do it, but realize that your answer will be different based upon how much you've zoomed or what size screen you are looking at right now. Luckily, when you write this in your exams, everyone has the same size because they've printed it. Okay, so write down the name of the scale. It is a bar scale. Bar scale. Okay, use the scale for 5 marks. Use the scale to calculate the actual length of the animal in meters. Now, calculating the length of this animal, I mean, you might think maybe we could do it like that, but you got to go from the most outside point. So let's drop it to there, and then the most outside point is over there, and let's just measure from between those two. Okay, so that you would use let's first have a look at this. Okay, so you'll take your ruler and you would measure this length. Now I'm not even going to use a ruler because I know that I've zoomed the question in more than what it would have been, or less than what it would have been in an exam paper. So I'm going to go look on the memo and see what this measurement is. So you would take your ruler and measure that length. Let's see. Okay, so you would have gotten around 2.1 centimeters. So you might have got close to that. You might have even gotten exactly that. But just based upon the zoom, it can be different. So, okay, so this length, if you measured it on your ruler, it's 2.1 centimeters. Okay, so 2.1 centimeters is the same as 1.9 meters. So this is on the map or on the diagram. And then this would be real life. Okay, so what you would do next is you would take your ruler and you would measure this entire length. Okay, now that entire length, if you do it correctly, is 15.1 centimeters. Now, is that how long the whale is in real life? Of course not. That's tiny. That is the length on your ruler. Okay, so let's take all of this away. Okay, so 15 centimeters is length of whale on diagram. Okay, so we know that 2.1 centimeters is the same as 1.9 meters. Now I need to get that to become a 1. So what I do is I divide by 2.1. So let's just divide by 2.1. But what you do to the one side, you do to the other side. And so 1 centimeter will be the same as... Now don't round off because this is not our final answer. So okay, I'm actually just going to write it as a fraction. 19/21 meters. Great. So now we know that 1 centimeter is the same as 19/21 meters. Now we know that the length of this whale was not 15, it was 15.1. So then, so if 1 centimeter is that many meters, then 15 centimeters would be 19 over 21 multiplied by 15.1. And that'll give us 13.66 meters. But now with rounding, sometimes we use 2 decimal places, sometimes we use 1. With this one, they're only using 1 decimal place here, so the correct way would be to round this to 1 decimal, which would be 13.7 meters. Then this, whoops, what's going on? Oh, can you see? Okay, so this part says that this animal weighed 20 tons. Convert 20 tons to kilograms. Okay, so you should know that 1 ton is the same as 1,000 kilograms. So to go from, so all you're going to do is 20 tons, you're just going to say 20 multiplied by 1,000, and that's going to give you 20,000 kilograms. Due to the global fish crisis, only 30,000 tons of tuna may be caught per year. The true quantity of tuna that is caught is closer to 48,000. Calculate the percentage of illegal fishing. Okay, so there is a total of 30,000 tuna or tons of tuna that you are allowed to catch. Okay, but these people are catching 48,000. So how many tons is illegal? Well, the illegal tons would be 48,000 minus 30,000, and that would be 18,000. So out of a total of 30,000 that you're supposed to do, 18,000 are being illegally caught. So to get that as a percentage, you say multiply by 100. And that'll give you 60%. Okay, so there was a lot of questions that I saw in this so what I'm going to do is I'm going to split the questions up onto individual pages. So we'll have some there, and then we'll have some there. Okay, just so we can see everything a bit better. So, what was that? Oh yeah, that's something. Okay, that's the same thing. Okay, so it says, here we have got a map. Perfect. Now it says, name the metropolitan roads found on the map. So remember, metropolitan roads usually, well, they always have an M. Okay, so here we've got a M9, M18. So we could say that M9, M18. What else? Is that the only metropolitan roads? Yes. Okay, 2 of them for 2 marks. Makes sense. List the major national road. So a national road has an N that links Blue Water Bay to Kucha. So Kucha is over here, and Blue Water Bay. Blue Water Bay. Where are you, Blue Water Bay? Here. Okay, so to go from Blue Water Bay to Kucha, you go along this road, and if you see, that is the N2. So we're just going to say here, it's the N2. Then this question, identify the provincial, why is this also 2.3.2? That's 2.3.3. Identify the provincial. Provincial, remember, is with an R. Remember, it's provincial is with an R. Metropolitan is with an M. And national is with a N. So it says, identify the provincial road between Abayi and Dispatch. Okay, so Dispatch is there, and then Abayi. Where are you, Abayi? Here. Okay. So to go between those two, you would travel along this road over here. And so you can see that if you look here, it's the R75, R75. So it R, the R75. Okay, so it's R75. R75, there we go. This one says, how many provincial, remember provincial is with an R, how many provincial roads are indicated on the map? Okay, so let's go see what we can find. So let's take away all of this. And we just got highlights. So we've got R368, R75, R367, R334. Whew. R3, okay, we've already got R367, R335, R334, we've already got that one. R102, there's another one. R75, we've already got that. R367, we've already got that. R102, we've already got that one. Okay, so it's 1, 2, 3, 4, 5, and 6. So we will just say here 6. There we go. Mr. Tulani stated that the measured distance on the map from Motherwell to Bluewater Bay, so from Motherwell, okay, to Bluewater Bay is 5 centimeters, and the actual distance is 13 kilometers. He further said that the scale of the map is 1 to 260,000. Verify if his statements are valid. Okay, so there's many ways we could do this. What I would like to do is I'm going to use the scale that he says, and I'm going to take this 5 centimeters, and I'm going to use the scale, and I'm going to see, do I end up with 13 kilometers? So ignore the 13 kilometers, and let's take his scale, 5 centimeters, and his scale is 1 to 260,000. Okay, so what this means is that 1 centimeter would be 260,000 centimeters. But he said that it's 5 centimeters. Okay, so if you multiply this by 5, you're going to get a 5. And then what you do to the one side, you do to the other side. So if you multiply this by 5, we get 130,000 centimeters. Okay, so the 5 centimeters on the map is giving us 13,000 centimeters in real life. But they've used kilometers, so let's just convert that to kilometers. So for that, we'll use our conversion. So remember, between here it's 1,000, between here it's 100, between here it's 10. If you go this way, you multiply. If you go this way, you divide. Okay, so if we are going from centimeters to kilometers, we will go to the left, so we will divide. So we will say 13,000, and then we will, well, not 13,000, it's a bit more than that. Careful, 1, 2, 3, 4, 5. 5. And you're going to divide that by all the numbers that we pass. So we're going to divide that by 100, and then we're going to divide that by 1,000, and that gives us 13 kilometers. He is correct. So we could, so you'd show all of that I've just showed, and then you would just say that his statement is valid. There are other ways you could have done that question, actually. I'll show you another way. So you could have ignored this, and then you just look at these two, and okay, so we know that 5 centimeters, he says that is going to give you 5 centimeters on the map. He says is going to give you 13 kilometers. Okay, so we need to get this into a scale. So the first step is you need to change both of these to the same units. So I'm going to change this one into centimeters. So you know how we normally do this: meters, centimeters, millimeters. So if you are going from kilometers to centimeters, remember this is 1,000, this is 100, and this is 10. So if you go that way, you multiply. So if you say 13 kilometers, and then to change into centimeters, you're going to multiply by 1,000 and multiply by 100. So that's going to give you 5 centimeters. Okay, great. Now we have centimeters and centimeters, so we can ignore that. Now, when we want to get a map scale, we always want this number to be a 1. So to turn that number into a 1, we divide by 5. What you do to the one side, you do to the other side. And so 1 will be equal to 260,000. And so we now have 1 to 260,000. So that's the other way you could have done it. Okay. Okay, this next question says, determine the time in minutes and seconds taken by the Tulani family to travel from Motherwell to Bluewater Bay. Okay, if they traveled by car at an average speed of 80 for a total distance of 13. Okay, so it says use the formula time is equal to the distance divided by the speed, which is 80. Okay, now if we go calculate that, don't round off your answer. Okay, it's 0.1625. But now what is this? Is this hours, minutes, or seconds? Well, here we're using hours, so this is going to be in hours. Okay, now they want the answer in minutes and like minutes and seconds. So let's go convert this into minutes. So we know that 1 hour is the same as 60 minutes. So if you have 2 hours, well then that's 120 minutes. So to go from hours to minutes, you multiply by 60. So to go from hours to minutes, once again we multiply by 60, and that'll give us 9 and that'll be now in minutes. So now we've got to be careful. We know that the 9, that's 9 minutes, okay? 9 minutes. But this 0.75, you can't say 9 minutes and 75 seconds. Remember, that's not correct. So I'm going to say 9 minutes plus 0.75 minutes. Okay, I'm not changing this to seconds. Well, yeah, I've kept it at 0.75 minutes. So this is 9 plus 0.75. So we still got the same thing. Now, what we're going to do is we need to go and change this one into seconds. So remember, in 1 minute, there is 60 seconds. So to go from minutes to seconds, you multiply by 60. So what I'm going to do is I'm going to multiply this by 60, and that'll give me 45 seconds. So now we have 9 minutes and 45 seconds. 9 minutes and 45 seconds. The diagram below shows, first thing, sorry, I wanted to mention, there are going to be more questions on the next slide, so there. Okay, so the diagram below shows the floor plan of the living room of the Sakutu family's house. Okay, so this is looking at from the top. This is their floor plan. Study the information below and answer the questions. Okay, so the length is 850. They've told us that. The breadth is 3.5 meters. Please keep in mind, this is in centimeters. This is in meters. Okay, and then the height is 10 centimeters. What are they talking about? Well, obviously, this is looking at their house from the top. But obviously their house has a height, okay? And so the height is 10 centimeters. Which doesn't make any sense, guys. 10 centimeters is like this, or 10 centimeters is like a ruler. Or like it's not a ruler. It's like a ruler is about 30 centimeters, so a ruler is about that length across the screen, or across my laptop screen. You might be on a cell phone. But just think about it, like a ruler is 30 centimeters. So they're saying that their house is 10 centimeters. It doesn't make sense. And you might say, yeah, but Kevin, isn't that because of the scale? Yeah, not really, because there's no scale in this one. And these lengths, like that's this is a proper real life length. But anyways, it doesn't matter. Let's just go with what they've given us here. So just keep in mind, that's in centimeters, that's in meters, that's in centimeters. Okay, so the first question. Calculate the perimeter. Remember, perimeter is the distance around the shape. So you don't have to use these formulas, but if you want to, we can. So it says, but they wanted the perimeter of the living room in millimeters. Okay, so we need to remember how to convert. We've got kilometers, meters, centimeters, millimeters. Now, in between here is 1,000, over here is 100, and over here is a 10. Remember, when you go this way, you multiply. When you go this way, you divide. So they're using this formula, so they're not using the height right now. So we need to change both of these into centimeters. Millimeters, because that's what they've said. So let's take this first one. So it's going to go from centimeters to millimeters. So if you go this way, you multiply. So we're going to say 850 multiply by 10, and that's going to give us 8,500 millimeters. Okay, then we're going to go convert this one. So now this one is a meters, so it's in meters, and we want to get it to millimeters. So we're also going to multiply. So we're going to say 3.5 multiply. Now you're going to multiply by all the numbers that you pass. There's 100, and then there's a 10. And so that's going to give us 3,500 millimeters. Okay, now we can go use their formula. So perimeter is going to be equal to 2 times. Now the length is, the length was this one, but now it's this, so 8,500 plus the breadth, which is now this one, which is now here, so that's 3,500, and so that's going to be 2 multiplied by, what's that, 12,000, and that's going to give us 24,000 millimeters. Okay, this next question says, calculate the area of the floor in meters squared. Okay, so now they want us to use meters. So luckily this one is already in meters, so we just need to convert this one. So if we take 850 centimeters, now we are converting centimeters into meters. And so we're going to go this way. So when you go to the left hand side, you divide. So we're going to divide that by 100, and that'll give us 8.5 meters. So we can then say that the area is equal to the length, which is now 8,5, multiplied by the breadth, which is now 3,5, and that'll give us 29.75 meters squared. Okay, carrying on. So it says that if a concrete floor which is 10 centimeters thick, that's where the height is coming in. It's not the height of their house, it's the height of the concrete floor. Okay, is to be laid, how many cubic meters of concrete will be needed? Volume is equal to length, breadth, height. Okay, so, and it says how many cubic meters. Okay, so they want us to use this formula, but we have to use meters. So remember the length, we already converted that, it was 8,5. The breadth we know is 3,5. So we need to change this now to meters. So remember once again, so it's 1,000, 110, and then if you go this way, multiply. If you go this way, divide. So if we have 10 centimeters, so centimeters, and we want to convert that into, what are we using again, guys? Oh, meters. We're going this way. To go from centimeters to meters, you go left, and that means divide. So we're going to say 10 divide by 100, and that'll be 0.1 meters. Okay, so now you can go work out the volume by just saying 8.5 multiplied by 3.5 multiplied by 0.1. And that'll give us 2.975 meters cubed. Cubed because we're doing volume. Okay, last question. In which direction does the width of the living room walls face? Now, be careful. Don't just assume the top is always north. Here they've actually done it like this. So this is actually north. This is south. That means this is west and this is east. Okay, you might have to just think about that. So it says, in which direction does the width of the living room walls face? Okay, so the width is the same as the breadth. So this was the length, and then this would be the breadth or the width. So it's these two walls here. So they're facing, some of them are facing west and the others are facing east. So we will say west and east. Okay, remember they weren't talking about the length, they were specifically talking about the width, which is the same as the breadth. I think they got that part of it mixed up there. Okay, so this diagram below represents a picture of the southern wall of the Sokutu family's living room. By the way, this question does carry on onto the next slide, so there we've got more questions. Ooh, we got a nice 9 marker coming. Nice. Okay, this diagram below represents a picture of the southern wall of the Sokutu family's living room. Okay, so this is the wall in their house. Okay. And they carefully selected red bricks for the wall. Nice. This diagram is not drawn to scale. The following information indicated on the diagram below is useful for calculation. Okay, so we know that this height is 5 meters, the height of the wall. Okay, they also tell us that the wall dimensions, we've got a height of 5 meters. Okay, so that's the height of the wall itself. The length is 850. Okay, so that would be that part over there, 850. And then they'd give us the dimensions of a brick. And then they also give us the area of a brick. Okay, I'll explain that now if we need to get to that. So it says here, first question for only 9 marks. Determine the number of bricks needed for the southern wall shown in the diagram above. Note the dimension of one brick excludes the mortar, which is 10 millimeters. Okay, so remember that your mortar is the stuff that goes in between. Okay, so they've made it pretty straightforward. We're just going to go use this formula over here. So we just need to go find the area of the wall. So what is area of the wall? Well, it's going to be this length multiplied by this length. It's a rectangle. Can you see that? We're just going to go work out the area of that rectangle. Okay, but they want us to use meters squared. So this length over here is already in meters. It's 5 meters. That's excellent. We just need to change this one into meters. So remember to convert, we use our distance conversions, which are these ones over here. And we know that in between here is 1,000, 100, and then 10. And when you go this way, you multiply. When you go this way, you divide. So if we have 850 centimeters, so we have centimeters, and we want to convert that to meters. So because we're going to the left, we will divide. So we'll say 850 divide by 100, and that'll be 8,5 meters. Okay, so we've got this length now. So now we can go work out the area of the wall. So area of the wall, and that's going to be 8.5 multiplied by 5, and that'll give us 42.5 meters squared, because it's area. Okay. Okay, now for the bricks, because we've done the area, as we said, we've done the area of the wall. Now we need to do the area of one of the bricks, but you got to be careful with how we do this one. So what we can notice is that if this is the wall, if you look carefully along the side, there's no mortar on the side, okay? So the bricks just start off normally there. But let's say, for example, we're over here. So what it would look like is there's a brick, okay? Then there's going to be mortar over there. There's also going to be mortar over there. And then there's also going to be mortar over there. Then you're going to have your next brick. Okay. And then there's also going to be a brick underneath over here. And then there's also going to be a brick over here. And then in between all of that there is mortar. Okay. Now. Oh, and then also over here. Okay, and then also over here. And then, yeah, so you get the idea. So for us to be able to make sure that we get the exact area of all of this, well, are we trying to see how many bricks we can fit into here? So we cannot ignore the mortar. So how could we include it? Well, what you can do is you can pretend that this mortar over here, okay, you can say that that belongs to this brick. And you could say that the mortar on the top also belongs to that brick. So that brick and mortar is now taken care of. Now, if you do that for all of them, it'll work. If you say that this brick has the mortar to the right of it, okay, and then there is mortar above, that'll work. And then if you look down here at this brick, you could say that you must calculate the mortar to the right of it and the mortar above. That'll take care of all of that. And then, for example, this brick over here, you could take its area, plus you could take all the mortar to the right of it, and then all of the mortar above it. So by doing that with all of the bricks, we will take all of the mortar into account. You might say, yeah, but Kevin, there's going to be, for example, there's mortar left over here. But remember that there is actually bricks there. I just haven't gone and drawn everything. So there would be bricks over there as well. Okay? So my strategy that I'm telling you is add the mortar to the right and above to the brick. By doing that, we will make sure that we have captured all of the mortar. What you don't want to do is take the mortar to the right, the left, the top, and the bottom per brick, because that'll cause a problem. I'll show you what I mean. This is quite complicated. It's quite weird. So let's say we have 4 bricks. Whoops, let's make them a bit closer. Okay. Now, if you say that we know that there's mortar in between them, okay? So let's actually make these closer. Okay, so there'll be mortar in between them, right? Okay, now if you look at this brick over here, and if you say that you are going to go and count all of this mortar for that brick, and all of this mortar for that brick, all of this mortar, and then all of this mortar, that won't be correct, because then when you go to the next brick, you can't include this mortar because it's already been taken. And so what you'll notice is that, and for example, if you try to calculate this brick, you can't take its mortar at the top because that's already been taken. So you're going to end up with, you're going to add, it's not going to work out. And that's why the only way to make it work out is that for each brick, just choose the mortar to the right. So we can choose, for example, this brick. We can choose all of that mortar and then choose all the mortar above. And then if you do that for each brick, then you won't be double counting anything. So that will be taken and that will be taken. And then for this one, it'll take everything above and everything to the right. And then for this one, it'll take everything to the right and everything above. And if you keep that pattern going, because remember there's also another brick over here, for example, if you keep that pattern going, then you're not going to double count any of the mortars, and all of the mortar will be taken into account. This is really a weird question, okay? If you're finding it tricky, don't worry so much. It's a bit of a silly question, to be honest. So if we now go look at the brick, or a single brick, also remember that we're going to count the layer of mortar on at the top, and then we're also going to count the layer of mortar along the right-hand side of it. You could have also chosen the bottom and the left or whatever. Just choose one either top and bottom and one either left or right, okay? So we know that the mortar, this length here, is 10 millimeters, and then this height over here, let's draw this a bit bigger. Okay, and then let's just put our mortar there. Whoops. Okay, so we know that the mortar goes 10 millimeters, that's its thickness, and then it also goes 10 millimeters that way. Okay, so now you could just think of it as we could just try to work out the area of this 1 unit. Okay, so as I said, we're going to think of this as 1 unit now, and now we need to go and find the area. So we know that the length, where's the brick? The length of a brick is 222. So that length there is 222 millimeters. I said that weird. And then this height here is 73 millimeters. Okay, but now what I'm saying is let's just include the mortar. So if you look at this height over here, it's going to include that 10 millimeters, so it's going to be 83 millimeters. And then if you just extend the mortar on this side, it's going to be 232 millimeters. There we go. Now we don't have to worry about this mortar anymore. And now we actually just have one structure like that. And now we're going to go work out the area of that structure. Sorry, that's millimeters. We're going to go, let's just write that. And then once we've got the area of that section, and then we can go work out here. Okay, it's a bit weird that they said 1 brick, but it actually means 1 brick with mortar. Okay, so that is a bit confusing. So to get the work, to go work this out in meters squared, we're going to have to convert these into meters. So to do that, we'll use our conversion. So for 83 millimeters, so if you're converting millimeters to meters, then you are going to the left where you will divide. And so you're going to say divide by 10 and then divide by 100, and that'll give you 0.083 meters. Okay, and then if we go and do the same with this one over here, we're going to say 232 millimeters divided by 10 divided by 100, and that'll give us 0,232 meters. Okay, so now we know the lengths of this brick. Oh, I'm actually so over this question, hey guys. And 0.083 meters. So now we can go work out the area. We know that this is a rectangle, so it's just length times breadth. So it's 0.083 multiplied by 0,232, and that'll give us 0.019256 meters squared. Okay, so now we can go and take the walls area. Whoopsie, not that one. That one there. And so that's going to be 42.5 over 0.019256, and that'll give us 2,207.1. But now you can't buy 0.1 bricks. Now some of you are going to make a mistake here, and you're going to say, oh, let's just round it down. But then your wall's not going to look correct. So you actually have to go and buy extra. So you're actually going to buy 2,208 bricks. And maybe the last brick you're going to somehow try break it up a bit and fit it in. But you can't round down, because then your wall is going to be empty. There's going to be a little piece missing. So you have to round up sometimes, even though you wouldn't normally round that number up. Okay, so there we go, 2,208 bricks. Woo, I'm happy to be done with that question. That was quite a challenging one. If you found that challenging to understand the mortar, I don't blame you. I think that would have caught me out on some days as well. Like, it's just weird. Okay. The builder suggested that an additional 10% bricks should be ordered to cover for the wastage. Calculate the total number of bricks needed for the boundary wall. Okay, so I don't know what they're talking about with this boundary wall. Don't worry about that. We're just getting an extra 10% of the bricks. So we know from the previous question that we got 2,208 bricks. So we're going to take 10% of that. So 10% of 2,208. We know that that means, if you type that in the calculator, it's just 0.1. Of means times, and that's going to give you 220.8 bricks. Once again, you cannot order a 0.8 of a brick, so you would round that to 221 bricks. Now the question says, calculate the total number of bricks needed for the wall. I don't know why they've said that. So you're just going to say 2,208 plus 221, and that's going to give you 2,429 bricks. Okay, this question says, the price of one brick is 4 Rand 75, VAT included. Calculate the total amount to be spent on bricks. Use your answer from question 3.2.2. Okay, this one's easy. So we know that we're going to order 2,429 bricks. Each brick is going to be 4 Rand 75. So if we go ahead and calculate this, that'll be 11,537 and 75 cents. Whoops, that's a 7. Jonah Mower, that's an interesting name, buys a small fish tank from the aquarium shop, whatever, for the price of 472 Rand. VAT is included. He wants to present the dimensions of his fish tank on a piece of paper, because that's what people do, right? You go buy a fish tank, and then the next day you take it to school with a little drawing on a piece of paper to show everyone the dimensions of your fish tank. Okay, now I'm being sarcastic. His father is an architect who told him to use a scale of 1 to 30. Jonah, if you're going to show your... Okay, Kevin, we're not telling a story here. Okay, sorry guys, I've been recording for a long time today, so I am feeling it. I'm going a bit crazy. This table below shows the dimensions of the fish tank. Study the table and answer the questions. Okay, so luckily it's not a circular fish tank. There's no pi or radius here. So it's just a normal fish tank. Let's quickly draw it out. Okay, so the length is 1.05 meters. The width 0.3 meters, and the height is 0.45 meters. Okay, excellent. Now, what do they want us to do? They said note that volume is equal to that times that times that. Fantastic. 4.1.1, refer to the table above. Okay, we're looking at the table above. Use the scale to calculate the missing value A and B. All right. Oh, I see. Okay, so these are the dimensions in real life, but they want us to now give the dimensions on a piece of paper. And remember, the father said use a scale of 1 to 30. So 1 to 30, remember the smaller number is always so that would be on paper, and then this would be in real life. In real life. Okay. So, but here they want it in centimeters, here they want it in meters. Wow, challenging. Okay, so it's okay, we'll get this right. So they want us to calculate, okay, well pretty much it's this. Can you see that the real life one is 30 times larger than the paper one? So if we already know the height in real life, how could we convert that into the paper one? Would we multiply by 30 or divide? Well, remember, the real life number is bigger. So this is the real life number. So what we'll do is we will take that 0.45 meters and we will divide it by 30. And that'll give us 0.015. But that's still going to be in meters. Now they would like it to be in centimeters. Okay, so then we know our conversions: kilometers, meters, centimeters, millimeters, 1,000. 100, whoops, if you heard myself in the background, my bad. Multiply, divide. So if we are going from meters to where they want us, centimeters. Okay, so we're going to the right, so we would multiply by the number in between, which is 100. So we would say 0.015 multiplied by 100, and that would give us 1.5 centimeters. Okay, so now we're going to go do the same thing for, that's A, by the way, that's A, and now we're going to do the same thing for B. So we're going to say 1.05 divided by 30, and that gives us 0.035 meters, okay, because it's still in meters. And then we're going to convert that by saying 0.035 multiplied by 100. And that'll give us 3.5 centimeters. And that's B. So A is 1.5 and B is 3.5 centimeters. This question says, determine the volume of the small fish tank in centimeters. Okay, so... But now this can be a confusing question. They're saying determine the volume of the small fish tank, but they're not talking about the centimeter values that we just got here. In those values are the dimensions on the piece of paper. They want the dimensions of the small fish tank. So we're going to use these values, but they want it in centimeters. Oh, so much converting. So we're going to go and convert all of these now into centimeters. So we're not going to divide by 30 or anything like that. That was just to take the fish tank and draw it on a piece of paper. That's not what we're doing in this question. Here we're just trying to find the volume, but they want centimeters. So we'll go change all of these. And we're just going to use our conversions over here. Okay, we're not using the 30 at all for this question. So we're going from meters, which is here, to centimeters, which is here. So we're going to the right. When you go right, you multiply. So we're going to say 0.45 multiplied by 100, and that'll give us 45 centimeters. Then for the length, we're going to say 1.05 multiplied by 100, and that'll give us 105 centimeters. And then for the width, we're going to say 0.3 multiplied by 100, and that'll give us 30 centimeters. Now we can take this formula and go work out the volume. So volume is going to be length 105, width 30, and height 45. And that'll give us 141,750, and that would be in centimeters to the power of 3. So 141,750 centimeters to the power of 3. This question says, how many liters of water will the tank hold if it is 90% full? Oh, that's important. You may use 1 centimeter can hold 1 milliliter. Okay, so we know that the tank measures this many centimeters. Okay, so they've told us that 1 centimeter is the same as 1 milliliter. But this is how many centimeters cubes we have. So then we can say 141750 centimeter will be the same, because it's 1 is equal to 1. So that's how many milliliters we would have, 141750 milliliters. Now, we've looked at lessons where you can convert, for example, kiloliters, liters, milliliters. And in between these numbers, it's always 1,000. And once again, when you go this way, you multiply. When you go this way, you divide. So if we are now going to go from milliliters, which is over here, and we want to go this way to liters, because that's what they said, how many liters, then we're going left, so we will divide by 1,000. So we will say 141750 divide by 1,000. And that'll be 141.75 liters. But now that would be if the tank was completely full, all the way to the top, right? But they said that it is 90% full. So we need to find 90% of that number. So 90% of 141.75. Now, we know that if you type this on the calculator, it'll give you 0.9. Of means times. And if you calculate this, you end up with 127.575, and that would be in liters. Alright, so this question does carry on. We've got this part over here and then this part over here. The winner was selected randomly. Mr. Sokoto won the grand prize of 150,000. Okay? So this part's a bit weird. It makes you think like there was a previous question. Just don't worry about that one. Mr. Sokoto wins the grand prize of 150,000 rand. He submitted 1,000 entries out of a total of 10,000 entries. Okay, so there was like a raffle competition and there was 10,000 entries in total, and this dude went and purchased like 1,000 entries. Geez, like this guy's eager to win some cash. He further decided to use 90,000 rand from the 150 to extend his single garage, which is currently over here, and he wanted to extend it to a double garage, which is over there. Okay, so pretty much this question is about a dude who wins 150,000 rand. Of the 150,000 rand, he's going to use 90,000 to upgrade his garage. Okay, he had a draftsman draw up the plan. The plan is drawn below. Okay, so this first question says, calculate the actual length and breadth of the existing and planned new garage. Okay, I read that a bit weirdly at first, but they just mean this whole part over here. Okay, in meters using the given scale. So here's the scale. So it's 1 is to 150. So remember, the 1 is always the smaller one. So this is on the diagram. And then this one is real life. Or you could call that the actual. So they said you calculate the actual length and breadth, so it's these values, of the existing and planned new garage in meters. Okay, so don't worry about the meters right now. What we're going to do first is, so we know that this is our scale, 1 to 150. So what that means is that the real life is 150 times more than the diagram. So for this first one, the length, it's 50.4. millimeters. So to work out that length in real life, you're going to multiply that by 150, and that'll give us 7,560 millimeters. We have not converted into meters yet. We've literally just used the scale. So this is now the distance in real life, but they would like us to have it in meters. So to do that, we know that we've got kilometers, meters, centimeters, millimeters, and when you go, there's 1,000 over here, 110, and then when you go this way, you multiply. When you go this way, you divide. Okay, so if we want to convert millimeters to, what are we going for? Meters. Okay, so we're going to the left, and so that means we will divide. And so we will say 7560 divide by 10 because of this number, and then divide by 100 because of that number. Okay, and if we do this correctly, we would get 7.56 meters. Now we're going to go use the exact same approach for the width. So we know that it's 25.6. So we're going to multiply that by 150 to get the real life length, which is 3,840. But that's still in millimeters. We have not converted it. Then to change it into meters, we will do the same conversion, and that'll be 3.84 meters. Okay, so now it says calculate the actual length and breadth. Okay, we've done that. Fantastic. Okay, this question says, calculate the floor space he will now have available in his new double garage. Give your answer to the nearest square meters. Okay, so they just want to know how much floor space does this dude have in real life. Okay, so that's going to be using these values. So we're going to say 7.56 multiplied by 3.84. And that'll be 29.0304 meters squared. But they said to the nearest square meter, so that would be 29, and so that's going to be 29 square meters. Okay, and then there's a last part over here. It says, okay, so remember we still got the introduction statement over there. Determine the probability of Mr. Sokoto not winning the competition, taking into account the number of entries he submitted. Give your answer in percentage format. Okay, so we know that there was 10,000 entries. Okay, so let's quickly see. If this guy wanted to win, and then over here I'll show you what to do to not win. So out of 10,000 entries, if he wanted to win, he had 1,000 out of 10,000 chance. Okay, but so think about this carefully. There were 10,000 tickets available. He only purchased 1,000. So what is the chances that he won't win? Well, he's actually got a very big chance that he won't win. There's 9,000 tickets that he didn't purchase. So it says the probability of not winning. So this is the one we're doing here. Don't actually worry about this one. I was just showing you what that would look like. And then you're going to say multiplied by 100, and that's going to be 90%. So there is a 90% chance that he won't win. Then it says, okay, that's weird. Oh, 4.3 was a question, and then 4.3.1 is another one. That's really weird. What is the probability of Mr. Sokoto winning the competition? Well, it's not impossible, but it's very unlikely. He only has a 10% chance of winning, and there's a 90% chance that he won't win. So we will say here, unlikely. It's not likely that he's going to win. Okay, then this question says, write 10% to 90% in simplified ratio format. Okay, so 10% to 90%. So because they both have a percentage, you can ignore that. Now, the number 10 can go into both of these. So I'm going to divide this side by 10, and I'm also going to divide this side by 10, and you're going to end up with 1 to 9.